Okay, today we are going to start.
Actually,
Yes,
सर एक मिड से रिलेटेड क्वेश्चन था, अभी कर लूँ या एंड में लास्ट?
what?
सर एक मिड से रिलेटेड मेरा क्वेश्चन था सर, वो मैंने आपको एक मैसेज चैट में मैसेज
मिड्स
किया हुआ था।
यार अभी मैंने देखे नहीं है मिड सारे, तो मैंने विल सी तो आप मैं देख लूंगा मैसेज।
चलिए ठीक है ठीक है, मैं check करूँगा।
So today we are going to start a new topic which is cylinder. In this topic we are going to study the different types of cylinders, and also we will see that what type of stresses and strains uh, do these cylindrical element bear. For example, as you are well aware that these cylinders are meant to contain fluids. Usually they have liquids and gases, but sometimes they usually have solid element as well, which are being stored in them. And whenever something is present inside this cylinder, those particular element, or if it's a liquid, it will exert some sort of pressure on the walls of the cylinders or on these caps or these end walls of the cylinder, and the material should be thick enough to resist this internal pressure. And this is the whole idea of doing studying this topic. Initially we will study that what type of stresses or what type of forces which can occur on different cylindrical walls, and then we will see that due to those particular forces, how the cylindrical element tend to resist those forces. And then based on the magnitude of those stresses or strains, because stress obviously will also produce strain.
Excuse me, sir.
And
Excuse me, sir.
yes,
सॉरी सर, आपको दरमियान में रोकता हूँ। सर आप एक अलग स्लाइड बना के ना तो ये कर लिया करें, रिकॉर्डिंग के अंदर ये फिर मसला करता है, समझ नहीं लगती है आप क्या लिख रहे हैं।
मुझे समझ नहीं आई आपकी बात, दोबारा बताएं।
सर ये आप इधर ही वर्किंग करना कर लेते हैं ना स्टार्ट, तो आप अलग से स्लाइड बना के ना तो उधर ज़रा कर दिया करें ये वर्किंग, रिकॉर्डिंग के अंदर फिर ये इशू करता है, समझ नहीं लगती कि आपने किया क्या।
I have already uploaded this slide on CMS just today. So if you want, you can download these from CMS. Okay.
ओके सर।
So these are available now. So based on those stresses and strain, we tend to decide that what should be the thickness of the material that we are going to use for the cylindrical element. And just for the introduction over here, these are the same thing, that the cylinder should be strong enough to resist all the stress and pressure due to these fluids. And if not, then obviously what will happen, that if you uh, place a fluid that is exerting way more pressure than the capacity of the cylinder, then it is definitely going to burst. So obviously, you know that the cylindrical element are of these kind of shape, and how you can play with this, you can increase the thickness of these walls. And as you keep on increasing the thickness of the resistance to resist the internal forces or forces due to the internal fluids will also continue to increase. But again, there are other factors as well that we need to consider. Since if we keep on increasing the thickness, then maybe there is a case that these two walls tend to come so close to each other that we won't have enough capacity for that particular cylinder. So in that case, usually the height or length of the cylinder is also increased to have enough capacity of the cylindrical element. And some of the common example, obviously, which we encounter every day or see commonly is the cylinder which tend to store the petroleum or which are carrying the petrochemical elements, and also the water cylinders are very common. And the design of these cylindrical elements is based on the stresses that we are going to study in this particular topic. And later on in reinforced concrete design or in those chapters, you are going to design the wall thickness or the reinforcement of the cylindrical element. And also another common example are the pipes, conduits or ducts in which the fluid is flowing under pressure are also kind of a cylinder. For example, you might have observed these kind of pipes. In these pipes, the fluid is obviously moving through pressure and it is exerting the forces on the walls of the cylindrical element. Obviously, it is open from both ends, but still it tends to produce some kind of forces on the walls. And due to those particular forces, the stresses are produced, and that is why they are also in the category of these cylindrical elements. So here are some of the pictures which are quite common and of these cylindrical elements storing different kind of uh, fluids or liquids or solids. Now coming on to types broadly, obviously you can distinguish the cylindrical elements in different ways, but one major distinction between the two cylindrical elements is based on their thickness. And the two types, and why it has been distinguished based on thickness, because you will observe when you will be solving the numerical problems as well, that there are different stresses in case of thin cylinder or in case of thick cylinder. The magnitude of stress the magnitude of these stresses varies in these two types of cylinder. And in this thin cylinder, for example, in the case of thick cylinder, there are circumferential, hoop, or longitudinal stress. All these three stresses. I will come later that what are these stresses, but for now you should only know the names. That there are three different types of stresses present in the case of thin and thick cylinder. But in the case of thin cylinder, the magnitude of these radial stresses is so small that it is usually neglected. So that is why they have distinguished these two cylinders based on their thickness, because there is a difference in the type of stresses that will occur in each type based on their thickness or wall thickness, you can say. So to sum it up, thin cylinders are the ones which have diameter more than 20 times the thickness of the wall. Or that means that the diameter will be so large and the thickness is so small that it is, or the thickness, or to put it in a criteria, the criteria is that the diameter is greater than 20 times thickness of this particular cylinder. Now this cylinder is called, can be classified as a thin cylinder, and all other cylinders are obviously thick cylinders. And when it is subjected, for example, when you will place a fluid in this cylinder, it will exert pressure on the wall of the cylinder. And due to these forces, or due to this internal pressure, three mutually perpendicular stresses will occur in this cylinder, and they are named as circumferential hoop stresses. Circumferential or hoop stresses is the name of are the same stresses. Then there are longitudinal stresses, and then finally we have radial stresses. I will explain in the next slide that what are the three what are these three stresses. So this is one cylindrical element. Now let's consider that we have this thin cylindrical element which has a diameter d and wall thickness as t, and it contains some fluid. Now this fluid is exerting a pressure P on the wall of the cylinder, and these each end of this cylinder is a closed cylinder. Now I will explain all the three stresses that are radial, circumferential, or longitudinal stresses by considering this longitudinal cylindrical element. Now first, let's talk about the radial stresses. Now radial stress is what? For example, when you insert a fluid, or when a fluid is passing through the cylindrical element, it is producing some sort of stress on the wall of this cylindrical element, or on each wall, because obviously the fluid will completely fill the cylindrical element, and it tends to produce the stress, or some it will exert some sort of pressure on the wall of this cylindrical element. Now, in order to resist this pressure or these stresses, the cylindrical element will produce equal and opposite stresses to resist this internal pressure. Now, that equal and opposite pressure or stress is called as the radial stresses. For example, let's suppose we have been provided with a fluid, and it says that this fluid is exerting 10 psi pressure on the wall of the cylinder. Now, an equal and opposite stress will be exerted to resist this internal pressure, and that stress is known as radial stress. And obviously, the name suggests because this internal pressure is being exerted on the whole radius of the cylindrical element. That's why these are called as the radial stress. And the formulation for this one is quite simple, that the radial stress is opposite in magnitude to the internal pressure. If you have been provided with this information that the internal pressure is 10 psi, and if someone asks what will be the radial stress that will be developed in this cylindrical element, you can simply say that it would be negative, or you can say that it will be 10 psi but opposite in direction to the internal pressure. Okay, this was about radial stresses. Then we have other stresses, that is longitudinal stress. Now let's consider the same element, and if I cut this element from of the first thing, as the name suggests, is the longitudinal. By longitudinal, obviously it means along the length of the cylinder. So if we cut different cross section along the length of this cylinder, for example, let's say this is my cross section A dash and A dash. Now what will happen? Now this is my, now let's suppose that over here, this section or this cross section is my A dash section, which I have shown in the previous slide. Now we know that this cylinder is completely filled with the fluid. Now this fluid is exerting on the left side, obviously, as I told you initially, that it is closed at both ends. Now the fluid on the left wall will exert some sort of pressure. So you can visualize then that when this fluid is exerting the pressure, it will tend to elongate this cylinder, maybe in some way like this one. Now, obviously, it tends to elongate, but our cylindrical element should be such that it should resist this elongation. Otherwise, the case is failure. If the cylindrical element tend to elongate, then obviously no one will pass that cylinder, and it will fail at some point. So the thickness or the dimension should be such that it should resist that extension or increase in length of the cylinder. So in order to resist this these stresses which are acting on the wall of the cylinder, we will have some stresses or opposite reaction which will be produced by the cylindrical element along the thickness of the cylinder. So this particular stress or these resistive stresses are called as the longitudinal stress. So you can, these are shown over here. It can be also shown along this particular thickness as well. So it is the same thing, that when the stresses are acting on the walls of the cylinder or on the end walls of the cylinder, then the resisting force which is acting at the wall section must be equal to the force produced by the bursting pressure. Now this is the resistive force, which is sigma L, or the longitudinal stress, and it should be obviously equal to this internal pressure which is acting over here. So this is known as this resistive force is known as longitudinal stress. And obviously, to have some sort of derivation for this longitudinal stress, we know, as I explained over here, that this internal pressure or internal stress is represented by P. And as we know that stress is equal to force over area, and over here the stress is P and area is A, and this is the force. Okay, so we know that this bursting force or the force that is acting on the end wall should be equal to this resistive force or this sigma L. So I can call this. Now can anyone tell me what will be bursting force over here? ये कैसे कैलकुलेट करेंगे? वी हैव दिस पर्टिकुलर रिलेशनशिप फॉर द कैलकुलेशन ऑफ फोर्स. इसको अगर मैं इसके साथ कोरिलेट करूं, सो कैन समवन एक्सप्लेन दैट हाउ कैन आई कैलकुलेट दिस बस्टिंग फोर्स?
प्रेशर को एरिया के साथ
I have to multiply it with the area. Over here, I know that area is this circular area. So for that circular area, I have one formulation, that P is the internal stress or internal pressure, and the area is pi d square over 4. What about resistive force? I know that resisting stress is sigma L. तो ये area कितना होगा? किस एरिया पे ये रेजिस्टिव स्ट्रेस लग रही है?
2 pi r t सर circumference के साथ मल्टीप्लाई करें।
So we know that this stress is being acting on this wall thickness या ये circumference पे रख रही है। तो circumference हमारे पास क्या होता है? 2 pi r, or I can write it as pi d, and also the, और अगर मैंने इसका एरिया कैलकुलेट करना है तो pi d से circumference आ गया, and if I multiply it with the thickness, so then it will give me the area. So if I want to calculate what is the magnitude of longitudinal stress, then I will simply simplify this particular equation and finally get this relationship for the calculation of longitudinal stress. Now, if I look into this equation, I can see that this internal pressure is a known quantity in every case because it is a factor of, it is related with the fluid or type of liquid which is inside the cylindrical element. And if I know the properties of that liquid, I can easily calculate what sort of internal pressure it will exert. And usually in the questions that you will encounter in this topic, this internal pressure will always be given to you. And this diameter and thickness are also the geometrical properties, and it should be given there for the cylinder which you are solving. But over here, I just want to explain one point, that what is this diameter? Will it be internal diameter or external diameter? Anyone?
External, sir.
Internal, sir.
इंटरनल
Why not?
सर आई गेस टेक्निकल के
सर
साथ राइट
डिफरेंस होगा दोनों का मेरे ख्याल से।
Difference होगा? Anyone?
इंटरनल सर
सर इंटरनल डायग्राम
अच्छा, अभी हमने एक चीज थोड़ी सी डिस्कस की थी कि जो थिन
सर
सिलेंडर है ना,
सर हम
ठीक,
एज का निकालते हैं ना तो उसका डिफरेंस नहीं यूज करेंगे।
नहीं, हम एच का
सर
नहीं निकालते। देखो, यहाँ पे हमारे
एवरेज होगा
पास,
सर।
यहाँ पे हमने एक डायमीटर कंसीडर किया था, ठीक है। अब ये डायमीटर कौन सा था? ये जो फोर्स लग रही है, ये जो इंटरनल लिक्विड है जो भी एंड वॉल पे फोर्स लगा रहा है, ये कितने डायमीटर पे फोर्स लगा रहा है?
इंटरनल डायमीटर
सिर्फ इंटरनल डायमीटर पे लगा रहा है, एक्सटर्नल तो बाहर है ना, वहां पे तो लिक्विड नहीं फोर्स लगा रहा, ये जो इंटरनल वाला है, ऐसे ही है। तो ये
यस सर।
डायमीटर तो हो गया इंटरनल डायमीटर, एंड देन यहाँ पे भी एक डायमीटर है। अब ये डायमीटर कौन सा है? अगर ये मैं इसका प्लान व्यू देखूं, तो यहाँ पे मेरे पास ये डायमीटर, ऑब्वियसली ये जो फोर्सेस हैं या ये जो पॉइंट लोड्स हैं या स्ट्रेसेस हैं, ये longitudinal stresses, these are acting on the center of this circumference. तो ये डायमीटर मेरे पास है एक सेंट्रल पॉइंट से लेके दूसरे फोर्स के सेंट्रल पॉइंट तक, अगर मैं पॉइंट इसके प्लान व्यू में ये देख रहा हूँ, ठीक है। तो देयर इज एन एम्बिग्यूटी, यू कांट सिंप्लीफाई कंसीडरिंग, अगर बाय द बुक चलें या अगर हम इसको स्ट्रिक्टली देखें तो ये दोनों डायमीटर डिफरेंट हैं, लेकिन हमने we just read one condition that in the case of thin cylinder, our diameter is very large compared, I mean that it is 20 times large compared to the thickness. Okay, so in these questions, usually it doesn't make much of a difference that whether we take if internal diameter or if we take the average of the diameter or if we take the external diameter. For example, if your internal diameter is given to you as 10 mm, maybe thickness is 0.05 mm, or it is 20 times less than the diameter. So 20 times is, I believe, something 0.5. Okay, so the thickness is 0.5. So external diameter will then be 11 mm. So it doesn't make much of a difference in the calculation of this longitudinal stresses. So you can consider either internal, external, or external diameter. But to be consistent with everything, we will be taking this diameter as internal in every question related to the thin cylinders that we will be doing later in this topic. Okay, so strictly speaking, it doesn't make much of a difference. You will see that if even if you take the external diameter, your stresses will come out to be almost similar. For example, if it is 9,000 psi By considering internal, it will be around 9010 psi, considering the external diameter. So you can take either one, but I suggest you to use the internal diameter just to be consistent with the literature that you will be studying for this topic. Is this clear?
Yes, sir.
So the third stress is this hoop stress or transversal stresses. Now, in this slide, you studied one word that all these stresses are mutually perpendicular to each other. I left this statement on purpose because in this figure you can get an idea that how these stresses are mutually perpendicular to each other. For example, first we studied this radial stress which is acting in this direction, which is shown over here or in this one. This stress, or in this, I will just circle it. This stress is radial stress, which is acting towards the right side. Then we have the longitudinal stress, which is acting along the length of the cylinder. And the third one is this hoop stress, which is perpendicular to both these stresses, or it is acting along the circumference of the circle. So it is for the same reason that these stresses are called the circumferential stresses. Over here, when we were considering the longitudinal stresses, we cut the section along the length of the section, or I can say perpendicular to the length of the section. Now, in the same way, if I want to calculate the circumference, just give me a moment. Now, in the same way, if I want to calculate the circumferential stresses, or if I want to make some derivation for that, I have to cut the section along the circumference of the cylinder. So let's suppose that this is or perpendicular to the circumference of the cylinder. Now let's suppose this is the section. I will call this as A dash again. Now let's suppose that I cut a section over here along the length, and this is the shape that I will get if I divide it into two sections. Now these stresses which are acting on the walls of the cylinder or perpendicular to this length is known as hoop stresses, and it is the same thing that is written over here, that assume a cutting section parallel to the length from the center, then the transfer force at the cutting section should be no, in the same way, just like we did in the case of radial stresses or the longitudinal stresses, that there should be some sort of internal pressure which will be acting on this surface, and that internal pressure will be balanced by these hoop stresses. Now, can anyone tell me what will be the internal pressure in this case if the fluid is present? Can I say that over this whole body, because suppose it is completely filled with the fluid. Now over this whole body in the vertical direction, it is exerting the pressure, right? So if I call this pressure as P, what will be the stress or what will be the force due to this pressure? What should be the force? Again, force is equal to stress over stress into area. So P I know is the stress. What will be the area on which this vertical stress is acting? Looking into this figure, can anyone tell?
D into L, sir.
Obviously the area should be जो भी जितने भी area पे वो लग रही है, and I know from this looking into this cylindrical shape that this dimension or the horizontal dimension is length, and the other dimension which I have is this one, and this dimension is d, and it is kind of a sphere shape or a rectangular shape. So the area on which it is acting is d into L. So this is the internal force which will be acting on this whole surface. Now, in order to resist this particular force by the cylindrical element, we will have hoop stresses which is acting in the opposite direction. Now that hoop stress is shown over here, and what should be the area of this, or on which area is this hoop stress acting?
L into T, sir. L.
Excuse me, sir.
We have, yes, yes, Any question? Okay, so this hoop stress is acting on this small thickness, or over here, this particular rectangle. On this particular rectangle, we have the hoop stress. Now, the area of this rectangle, obviously, one dimension is this equal to length, and the other dimension will be equal to this thickness. So, length into thickness will be the area of this triangle, rectangular shape. And obviously, we have two shapes in this particular cross section, one on the left side, and the other one which is shown over here as sigma h on this right side. So that's why we will multiply it with 2. Now this is the applied force or force due to the liquid, and this one is the resistive force. Okay, so these are the two forces that are acting, and again these should be equal in order to keep this cylindrical element in its original shape, or in order to keep it away from the failure. So this is the same thing which is shown over here, that the force induced by internal pressure is this PD into L. Again, this is diameter, this is length, and the resistive force that is shown over here is sigma H L into T, which is the area, and this 2 is due to the fact that it is acting on two rectangular shapes. So when I make them equal, then I will get this sort of equation, that PLD is equal to sigma HL into T into 2. And if I further simplify this one, I get this simple formulation for the calculation of hoop stress. Again, this P is the internal pressure, which is the pressure due to the fluid, or internal stress. You can actually just don't confuse it. It is the stress. Every time you see P, it is the internal stress due to the fluid which is present inside this cylindrical element. This D is again the diameter, and this T is the thickness of this cylindrical element. Now, if you compare these two equations, in these two equations, you can see that these are quite simple. And if I make one small correlation between these two, I can say that longitudinal stress is half of hoop stress. Okay, so this one is also quite common MCQ or objective question that you will encounter in different types of tests, that the longitudinal stress or the magnitude of longitudinal stress is half compared to the hoop stresses. So this is a brief discussion about different type of stresses which occur in the cylindrical element. Now another simple, yes.
सर ये जो रेजिस्टिंग फोर्स है ना सर, इसकी जो एरिया हम ले रहे हैं, तो सर ये तो कहीं से भी हम काट सकते हैं ना सर इसका, तो मतलब सारे जो सरकम्पेरेंस है उनका एरिया नहीं आएगा सर, यहाँ पे हमने सिर्फ जो है
देखो
ना
आप कहीं से भी काटोगे तो एरिया क्या बनेगा इस रेजिस्टिव फोर्स का?
लेंथ एंड थिकनेस।
एरिया तो सेम ही बनेगा ना, सेम बात है कि
सर और आल अगर हम जहाँ पे भी कट करें ना तो हर एक सेक्शन का यही होगा ना जो
यस
का एरिया।
यस
सर तो सम नहीं लगता फिर?
नहीं, जो आपके पास देखो सम, हाँ यू कैन से आप उसका सम लो फोर्स के केस में, लेकिन स्ट्रेस क्या होती है? स्ट्रेस के यूनिट्स क्या होते हैं? किलो न्यूटन पर मीटर स्क्वायर या न्यूटन पर मीटर स्क्वायर। ठीक है, तो मीटर स्क्वायर शो करने का क्या मतलब होता है कि 1 मीटर स्क्वायर पे इतनी स्ट्रेस है। हम वो नहीं शो कर रहे एब्सोल्यूट फिगर्स में कि फोर्स कितनी है, इसीलिए तो हमने ये फार्मूलेशन बनाई है, ये स्ट्रेसेस की बना ली है। ठीक है, अगर फोर्स होती ना फिर मैं कहता कि फोर्स 100 है या 200 है, उनमें डिफरेंस है। ये तो पर मीटर स्क्वायर है कि 1 मीटर स्क्वायर पे इतनी लग रही है। अब आपका एरिया कोई 1000 मीटर स्क्वायर हो, आप निकाल सकते हो कि उस पर कितनी फोर्स है। ठीक है,
सही, थैंक यू।
so coming on to this, and this is one simple concept. Usually क्या होता है आपके पास, फॉर एग्जांपल ऐसी कोई भी शेप हो, ठीक है, इस शेप में ना कोई स्ट्रेस प्रोड्यूस हो रही होती है। लेट्स सपोज वी हैव अ रेक्टेंगुलर प्लेट, we will have some sort of stress which will be acting on this one, and that stress can be calculated as F over A. Now let's suppose if I make some sort of holes or joints in this particular shape. अब इन joints से क्या होगा, या कोई भी मैंने इधर boards लगाने हैं let's suppose, तो मेरा cross section area जो है it reduces, right? When my cross section area reduces, if this is sigma 1, then sigma 2 will be f over a2. Now this area is small, and due to this small area, my sigma 2 will be greater than sigma 1. Now this factor shows that when the area reduces, the stress will increase, and when the stress increases, I should provide a strong, I should provide a thickness, or I should consider a material which is strong enough to resist this particular stress, right? So, in the same way, we do consider this concept in the case of cylindrical element. You might have observed the cylinder in which you provide such sort of bolts to make connections. Sometimes you don't have the die to make this sort of shape directly. For example, sometimes the diameter is 100 meters, for example, then you don't have a die to cast a 100-meter cylindrical element directly. In that case, you cast the rectangular sheets, and these sheets are then molded into cylindrical shapes, and you provide these joints to make a connection or to keep it intact in the cylindrical shape. Now, due to these particular joints, the area reduces obviously, and when the area reduces, your stress will increase. So in order to consider this factor, so when there are joints in the cylindrical element, there are two factors for each type of joint. There is a factor which is known as efficiency, or you can also call it as efficiency of the particular joint. So now these are fixed factor. For example, for different type of bolts that you place in the cylindrical element, for each bolt you have this factor given by the manufacturer. The manufacturer will specify that this is my bolt, and due to this bolt, this much stress will reduce for your cylindrical element. And you will then simply divide your hoop stresses or longitudinal stresses by this particular factor so that you get the exact value of stress in the case of these joints. And for longitudinal joints, you represent it by nu c, and for the longitudinal joints, you represent it for by the factor mu L, and you divide your original equation. These were your original equation for the stresses, and if it has been provided to you that there are some sort of joint, then you should always ask for this factor, that is efficiency of longitudinal joint. So the idea that you should remember is that due to joints, your stress will increase, and due to that particular increase in stress, we need to have a strong material so that it does not fail. Okay. Any question about this one?
सर ये गर्थ जॉइंट क्या है सर, वो नीचे लिखा हुआ है सर.
गर्थ जॉइंट का वही मतलब है कि जो आपके गर्थ किसको कहते हैं, आई बिलीव जो along the circumference, yeah, I don't exactly remember this, but I think this girth means the circumference or diameter. तो along the diameter जो joint दिया जाएगा उसको girth joint कहते हैं, या along the length जो आपको joints दिए जाएंगे, these are longitudinal. I'm exactly not sure, just Google this term, and I believe this term has the same meaning as of diameter.
सर वो
Okay.
गर्थ
Circumference है सर वो.
मिडल में होते हैं वो.
What?
सर ये मैंने अभी सर्च किया तो गर्थ का मीनिंग होता है मिडल में. तो जो मिडल वाले होंगे ना उन्हें जॉइंट्स, उन्हें गर्थ जॉइंट कहेंगे.
Joints along circumference है सर.
But I think the exact literal meaning of girth is of diameter. So along the diameter जो joints, क्योंकि ये भी तो girth joints हैं, these are not in the middle, right? तो girth का exact literal meaning is something related to diameter. But I will again check this one. But obviously, by looking into this figure, you can get the idea that these are being provided along the circumference of the triangle, so you can call them as a girth joint. Okay.
Excuse me sir.
Hmm.
सर ये सिलेंडर्स का सिविल के पर्सपेक्टिव से क्या यूज है? आई मीन ये मतलब ये डिजाइन तो कुछ मेरे ख्याल से मैकेनिकल वालों के साथ ज्यादा रिलेटेड है एज कंपेयर टू सिविल इंजीनियरिंग.
You can say that, but obviously, for example, as I discussed in the start, that these water tanks, these are related to civil engineering. Okay, so water tank, for example, when you are designing, it is an important component. When you are designing a multi-story structure, on that structure you have to provide a large enough water tank. For example, if you are designing a structure which has to have 1,000 people in it, to cater for the water demand for such large number of people, you have to design a water tank that is strong enough to hold that much water. And then later on, you have to consider the load of this cylindrical element or this whole body onto the structure at which it is being placed. And that load is considered in the design. Or yeah, it is an important part of your civil engineering problem. These are, I haven't talked about the material. Obviously, these cylinders can also be costed of the concrete. So concrete cylinders are very common, and it is up to civil engineer. It is the duty of civil engineer to approve the design of such sort of cylinders. So if you don't know the basics, what are the stresses or how you can calculate those stresses, then how can you proceed with that? Uh,
सर समझ आ गई.
for example, I also remember I did one internship at Fatima Fertilizers. Over there, I think half of the team of civil engineer is allocated for the casting of the cylindrical shapes because they have very huge cylindrical bodies to store their chemicals because their whole process is such that they play with chemicals to make their fertilizers. So they have concrete cylinders, and sometimes their cylinder is, for example, sometime when the load is so much, then they have to extend the dimension of their cylinder. So this whole thing has to be managed by a civil engineer. So even in the field, you will see these things. So
Okay, sir.
let's solve one simple example related to this thin cylinder. Suppose we have this cylindrical element which has an outer diameter of 12 inches and wall thickness of 0.125 inches. And we are supposed to calculate this radial, longitudinal, and circumferential stresses which will occur in the wall of the cylinder. And the pressure it has given to us as 200 psi. And we need to report radial stresses, hoop stresses, and the longitudinal stresses. So first thing first, what will be the radial stress? Can anyone tell me?
minus 200.
Obviously, the internal pressure is given to us as 200 psi. So radial stress is directly equal and
सर
opposite in
200
to this one. So that will be 200 psi. And what about the hoop stress? Over here, we develop this formula for the hoop stress, that is PD over 2T, and we simply need to apply this one. And for longitudinal stress, we have PD over 4T. So first, over here for the longitudinal stress, as I told you that we do need to consider the internal diameter. So the internal diameter, what will be the internal diameter of this cylindrical element?
11.975.
That will be 12 minus 2 into 0.125, and someone told me the answer just now.
11.75.
Yes, sir.
So that is 11.75. So what will be longitudinal stress? So if I substitute all the values into this one, the diameter is 11.75. 4 times thickness is 0.125. So what is longitudinal stress?
$73.4 psi.
4,700.
I think it is 4700 psi.
Yes, sir.
This is in inches and thickness is also in inches. So it comes out to be 47,000 psi. And what about hoop stresses now?
2,400 psi.
Obviously, it will be half of this one or double of this one, in fact.
Double of this one. 9,400.
So that comes out to be 9,400 psi. And just in this example, if you see that even if I consider the external diameter, the impact would not be that much. For example, if you consider the external diameter, which is given to you as 12, the stress will come out to be 4800 psi. And talking in psi terms, this is not a major difference. And usually we are reporting it in ksi. And if I report it in ksi, that will be 4.7 ksi and 4.8. And usually in the case of design problem, you directly consider it as a 5 ksi factor. And another thing which I want to mention over here is this radial stress. I believe I told you initially that in the case of thin cylinder, these radial stresses are so small that these are neglected. For example, if you see maximum stress that is acting is this hoop stress. And usually in the case of design, we will consider this stress, and based on this stress, we will design our cylindrical element. And once we have designed based on this stress, it will automatically satisfy this longitudinal stress and this radial stress. And comparing both these three stresses, we can see that these radial stress are very small, and in most of the cases, you are not going to calculate this stress. Straight away, you can say that, okay, in the case of thin strand, then the radial stresses are very small, and we will straight away neglect this one. So this is a brief introduction about the stresses which occur in the case of thin cylinder. So I am going to stop at this point, and in the next class we will start with the next thing, which is to study the strain in thin cylinders. So go through this lecture again and try to develop. This topic is simple one. First, we will do the same things for the thin cylinder. Then we will study the stresses for the thick cylinder. So as a whole, this topic is not quite complicated. Even the strain are quite simple. It's quite simple concept. So the purpose is that you should know what are the stresses and strain and how do you calculate these one. So any question about this one? Yes.
सर
सर ये
ये
प्लेट और जॉइंट के केस में जो
रियल स्ट्रेस
एरिया
आप
डिक्रीज हो रही है तो ये कैसे डिक्रीज हो रही है?
समझ नहीं आई मुझे।
सर जो हमने इससे पहले जो स्लाइड्स पढ़ी ना प्लेट्स और जॉइंट्स का जो इफेक्ट है उससे एरिया डिक्रीज हो रही थी तो हमारे स्ट्रेस जो है वो इंक्रीज हो रही थी। वो कैसे सर एरिया कैसे डिक्रीज हो रही है उस केस में?
एरिया डिक्रीज देखो, अगर आपके पास एक सॉलिड बॉडी है, इसका एरिया 10 है, ठीक है। अब मैंने इसमें जॉइंट्स डाल दिए हैं, ठीक है, यहाँ पे जॉइंट, यहाँ पे जॉइंट, तो आपने क्या किया है, इसके अंदर होल्स प्रोड्यूस कर दिए। अब इन होल्स की वजह से कुछ ना कुछ एरिया तो निकल गया ना इसके अंदर से। मतलब अगर पहले 10 था तो बाद में हो सकता है 8 रह गया हो। जब एरिया उसके अंदर से कम हो गया तो उसकी वजह से स्ट्रेसेस ज्यादा प्रोड्यूस होंगी, क्योंकि वी हैव दिस फॉर्मूलेशन दैट स्ट्रेस इज इनवर्सली प्रोपोर्शनल टू एरिया।
सर ये जो होल है ये हम क्यों प्रोड्यूस कर रहे हैं इसमें?
क्यों प्रोड्यूस करते हैं? देखो, आपके पास ना जरूरी नहीं होता है कि आप, अब ये सिलेंड्रिकल एलिमेंट बनता कैसे है, आपके पास कोई ना कोई या तो डाई कास्ट होती हैं। डाई क्या करती है, आप उसके अंदर मटेरियल लिक्विड फॉर्म में डालते हो और वो आपको ना बाय डिफॉल्ट सिलेंड्रिकल शेप दे देता है। ठीक है, अब वो सिलेंड्रिकल, अब जो डाई होती है ना, वो एक डाई एक ही डायमीटर और एक ही लेंथ का सिलेंडर कास्ट कर सकती है। फॉर एग्जांपल मोल्ड समझ लो, अब मैं मोल्ड के अराउंड जो है ना कोई भी लिक्विड मटेरियल डालूंगा स्टील का या जो भी है, और वो मुझे सिलेंड्रिकल एलिमेंट्स जब वो ड्राई अप होगा तो सिलेंड्रिकल एलिमेंट मिल जाएगा। अब ये तो हो गया कि आपके पास मोल्ड है। अब अक्सर केसेस में ऐसे भी होता है कि यू डोंट हैव स्पेसिफिक मोल्ड, आपको डायमीटर जो है वो स्टैंडर्ड से कोई वेरिड चाहिए होता है। फॉर एग्जांपल लेंथ आपको 5.6 ही चाहिए और डायमीटर आपको 2.3 चाहिए। अब इस शेप का मोल्ड बनाना भी एक काम है, उस पे आप इतना पैसा लगाओगे, तो उससे बेहतर फिर यही होता है दैट यू डायरेक्टली बाय अ रेक्टेंगुलर शीट। अब आप इस शीट को बाय करते हो, जिस तरह आपने मार्केट में भी देखी होंगी, ये जो you have cupboards, steel cupboards, or not steel cupboards, there are some sort of cylindrical shapes, उस वो फिर कैसे बनती हैं, you see you buy this rectangular sheet और इसके अंदर इतनी डक्टिलिटी होती है या इतनी फ्लेक्सिबिलिटी होती है that you mold it into this cylindrical shape, और इसमें आप इसको मतलब मोल्ड करते हो और यहाँ पे आप इसके जॉइंट्स लगा देते हो to keep it in this shape, राइट। तो रेक्टेंगुलर शेप से कोई सर्कुलर या सिलेंड्रिकल, तो उसमें आपको कोई ना कोई जॉइंट्स तो देने पड़ेंगे, तो उससे भी स्ट्रेसेस में आपका डिफरेंस आ जाता है। इज इट क्लियर?
ओके सर, यस सर, थैंक यू।
सर ये रेडियल स्ट्रेस कैसे आपने निकाला -200 psi?
इंटरनल प्रेशर गिवन था, तो रेडियल
sir.
स्ट्रेस क्या होती है, इक्वल एंड ऑपोजिट टू द इंटरनल प्रेशर, राइट।
कैसे? नहीं
सर ये DI किस तरह पॉइंट ये बता दे सर।
ये क्या था इधर,
अच्छा ठीक है सर, ठीक है।
पीआई, ये देखो ना, हमें पता है कि प्रेशर उसके अंदर इतना लग रहा है 200 psi। अब ये कोई फ्लूइड ही होगा ना जो प्रेशर लगा रहा है उसमें, तो वो ये इंटरनल प्रेशर है उसका।
एक्सक्यूज मी सर,
यस,
सर ये DI किस तरह पॉइंट ये बता दे सर।
पीआई,
यस सर, ये इंटरनल